And you can see those two timelines. One of the issues we have is performance and provisioning. Because in order to provision multiple VDIs or desktop environments, we have to clone from a template and distribute multiple instances of it. Well, it turns out that that's a heavy load. And I measured that load, and I had some issues with it. Let's see what it does when it does a clone process. So essentially, it reads some configuration files, creates a directory, writes the configuration files in a different named manner, new UUID, then it reads the source VMDKs block for block and writes the target block for block. It does that over the hypervisor's back end, provisioning tools. There are multiple duplication points in that process. Because we have an encapsulated VM, there are many points that are already existent. So you got over the network, over the transport protocols, etc. So there's a lot of extra work. Well, there are methods to eliminate it. So let's have a look at what we can do, and let's have a look at that workload first. This is a single VMDK clone. And you can see a normal CPU load, 1.5 gig. And the first half of it is actual writes to disk. The second half of it is, because this is a thinly provisioned VMDK, half of it's empty. But what the cloning process does is it fills zeros. And it fills zeros over the network. You can see the actual disk load is pretty much gone. It's finished. It's just creating metadata. Block exists, 0 bytes. Block exists, 0 bytes. Memory starts to diminish back down to normal. It's already stopped using it. So those two areas of CPU and network are heavily impacted by this cloning operation. So there are some solutions to that resource consumption. We can offload the provisioning and take care of it within the OpenStorage head. You could also use clones, snapshot clones. There's inherently a problem with the NFS client. Well, it's not really a problem. It's a designed limit to prevent excessive resource consumption. So the NFS client within VMware hypervisor will allow 64 mounts in ESX 4.1. 64 mounts means you're limited to 64 VMs. That's too small a limit. It's just the way that it turns out in NFS mounts and cross mounts and referrals. In this case, we don't have cross mount capability, so we can't expose more than that. And cross mounts aren't really any good anyway, because what a cross mount does is it's an NFS client at the storage head doing the work of the NFS client at the client. Well, you get a lot of those, and your performance will just degrade to nothing. As well, if you're provisioning snapshot clones, you're creating snapshots, your backup strategy is snapshotting, and it's transmitting that over a wire to another location, you are actually capturing snapshot clone activity. So again, wasted space, wasted resource. Well, we can actually take dedupe and see what we can do with this. Dedupe can provision a very good solution. We can use bash scripts, Perl scripts, many other VMware tools to provision the same clone operation directly on the storage head. There's no need to do all that work outside of it, because all those operations are actually done that way. But when you have NFS, you have the inherent ability to examine the file directly and work with the file directly on the OS. So it's one interesting advantage to using NFS. There's a cost. NFS is going to chew up CPU on both ends. So there will be a CPU hit for it. But the feature's so good that it's viable. So when VMware creates a clone copy, what it's actually doing is it's It's using a small, tiny little tool called deploy package. And that little tool is in vCenter, and it basically creates a cab file. And the cab file has some header space in it, and inside the header space is the commands it's going to execute inside of the VM that's cloned and created. You can create that cab yourself. Cab file tools are readily available, and you can create it, put the files you need into it, inject a little command set, and it'll launch and create your tools. So you do not actually have to provision this directly from VMware. Once you've created this VM, you can use PowerShell to invoke it, launch it, manipulate it, turn it off, move it, whatever. So to invoke a cab installation, it's as simple as adding a little tool to the VMware config file. So it's simple text editing at the storage head. Okay, so let's see what happens when we offload the cloning operation and place it directly on the OpenStorage head. This is a cloning operation of 5 concurrent VMDKs, or I believe they're 25 gig volumes, a lot of empty space, but they're templates, and it launches and runs for a significant while, about 12, 15 minutes, 20 minutes, long time. Well, let's see what happens when we do that in an offloaded manner directly on the OpenStorage head. There's the resource difference. So we're leveraging deduplication and scripts and automation in the background to provision the same 5 VMs. And if you think about that and look at the actual graphing, that's the difference in consumption. The real numbers are awesome. 274% less disk load, 200% less memory, and the unbelievable 83 million% less network. And that's simply because it's filling zeros, all unnecessary. There are other ways to offload this. Write same, it's coming. It'll be there, right? All these technologies will be there because VMware is unaware of some of the capabilities of the back end. It won't use them. So there has to be some integration tools plugging in and letting them know that it exists. But write same's coming, and write same SCSI commands will alleviate this kind of stuff in thinly provisioned VMDKs. It, however, doesn't solve all issues. There are other things. Offloaded mechanisms need to be created to smooth this out a bit. But what's important is you see a lot less CPU load, which is one of our problems. You don't want to consume a lot of CPU when you're deploying a new clone for somebody in the middle of operations. Oh, I need a PC. Okay. That's a lot of load. So you don't want to be doing that. Okay. Other optimization techniques is, remember, one SSD serves all. So if I put a single SSD in the hypervisor, it's going to accelerate all the VMs. So one serves all. Oops, sorry. Okay. Another important consideration is if we place user data on a separate volume, we have the ability to enable compression only on that volume. If we place our temp and swap files on a separate volume, we have the ability to accelerate write only on that volume. We can disable sync on that volume, which means that we're targetedly tuning each aspect of the OS behavior. And it's the OS behavior that kills you in VDI. Because if you launch a Windows 7 host or desktop, you're going to notice an extreme amount of activity initially, and then based on how it's tuned, it will either carry on that activity or cease and quiesce. And that's important to remember. So we need to control our I/O types, position them so that we can tune and optimize disk storage, memory, CPU, all those things, IOPS. So with that, in any OS, basically you need to do things like prevent or control, defrag, Windows updates, all those functions, dump. If dump was left configured and there's an exception, it's really going to hammer a VDI environment if it happens in parallel. And a comment yesterday that defrag doesn't matter. Well, actually it does, but we don't want to defrag during the day. So control is the point. And remember, from my security side, if an interface is available to a user, will they try it? Yeah. So rule number one, if it's not available, they're not going to cause a security incident. Another aspect is CPU-intensive processes, like the virus scanner doing a full scan on the entire PC while it's idle. Great. What you want when it's idle is zero activity. Meanwhile, you get heavy load. And it's got to be prevented, because in a VDI environment, that will collapse the whole CPU, starve it, everyone suffers. So you have to keep all of those things in mind when you're building it, and put a lot of pieces in place to make sure none of that happens. And memory-intensive routines, like why would you need search indexing on something that's already accelerated down to the storage head? No. Search indexing is not required, prefetch is not required, or at least just do it once on one head, and then it's all cached. And one reason I put this up here is this is an actual load of a defrag. 100% random IOP. The worst thing you could ever do to any disk. That's why we don't want that to happen. Okay, so an example of separated storage, all we're doing is we're tuning the OS, placing all the operating system files on the C volume, and trying to keep some of that noise I/O out of there. You can't take it all out. Microsoft makes it really, really difficult to do. There's no click, put data here. Not like Unix. Mount here, this is where I want it. In Microsoft, it's here's how we're doing it, like it or not. Data on a separate volume, because we want to tune, we want to dedupe primary volume, and we want to compress data. Much better option is to compress data. If you did know that you had a highly duplicated data environment, which is extremely rare in a VDI, I just can't see it. But if you do know it, then you could turn dedupe on, but unlikely. And noise, your worst enemy. In a noise scenario, swap file, temp file, what we want to do in our replication strategy or backup strategy is just send, destroy the snapshot. Send, destroy the snapshot. Primarily because there's no useful purpose in keeping it there, and if it's trashed, it can get recreated. You don't want it. And it'll reduce a lot of your IOPS, moving it over to the other store. Okay, so how many VMs do you think you can put on this thing? We have 500 gig. A little over. Well, let's find out. I ran my handy dandy little bash script, and I actually targeted 500 VMs, but I canceled the operation. There was no point. It would reach about 13,000 VMs before it exhausted the 500 gig. You see 499 gig left out of 509. So it doesn't take much space to duplicate when we're configured correctly. Because the data is not on the C volume. So we're keeping that randomization away from it. We're leveraging dedupe in a targeted manner. So a good heads up, when you're creating a VM that's providing storage, make sure you reserve memory and CPU. You probably increase some of the disk shares too, but I forgot to do that before I turned on all the VMs. Well, I didn't turn on 272 VMs because I would absolutely collapse this host no matter what you did. There's no way you can create that kind of IOPS on this little engine. I turned 30 of them on. 30 of them on consumed 16 gig of CPU, 27 gig of memory. It's definitely CPU bound in this case. There's four cores, 2.4 gig. It would easily support 30. Normal load, you could do that. 25 is probably a better idea for this target. This is a prototype for our development crew. They're going to run on this, and then we're actually going to promote that to production. And it's been through quite a few different use cases and pounded quite a bit. And it works.